Okay, and the final part now wants us to differentiate this twice, and it tells us the answer will be in this form. That's important later on. I'm going to start differentiating it. So just dy by dx to start with. And for that we're going to need to use a combination of the product rule, because we've got two terms here, and the chain rule, because we've got this e to the x squared. So product rule says differentiate the first one. So if we differentiate e to the x squared, we're going to get e to the x squared again, but times by the differential of the power. So the differential of the power is going to be 2x. So that's going to be 2x e to the x squared. And then we leave that bracket alone for the first part. We're then going to add on the differential of the bracket, which is going to be 2ax, leaving this one alone. So times by e to the x squared. So we then need to differentiate this again, but this one looks a bit of a mess. We've got three terms here that we would have to use the product rule for. So rather than doing that, I'm going to turn that into a two-term thing like we had here by putting the 2x back inside this bracket, so that I've just got e to the x squared on the outside. So that would be 2a x cubed plus 2bx, and it's just going to make it easier to use the product rule on it. So d2y by dx squared, we can then differentiate this, which we already know is going to be 2x e to the x squared, leave that whole bracket alone, plus leave the e to the x squared alone, and differentiate the bracket. So that's going to be 6ax squared plus 2b. And then we need to differentiate this as well, and that's a product too. So if I kind of do this as my two separate terms, differentiate the first one is going to be 2a, leave the second alone, plus leave the first one alone, differentiate the second one, which is going to be another 2x e to the x squared times 2ax. So that's going to be 4ax squared e to the x squared. Every single term has an e to the x squared in it, so if we take that out, let's see what we've got left. We've got 2x times 2ax cubed, so that's going to be 4ax to the 4, plus 4bx squared, plus 6ax squared, plus 2b, plus 2a, plus 4ax squared. Now if we go back to the very start of the question, it said the answer can be written in the form e to the x squared, which we've got, times an x to the power of 4 term and a constant term. So our x to the power of 4 term is here, and our constant term is here, which means these two parts, the x squared term and this x squared term, must be 0. They must add up to 0, because they're not involved in the answer. So 4b and 6a and this 4a over here must equal 0. If we tidy that up, that's 10a plus 4b, and we can divide by 2, and that gives us 5a plus 2b must equal 0. And that's what they gave us in the question. That's what we were trying to get to. Prove that 5a plus 2b equals 0. And that's what we've got.